So then you get x squared equals 78. So then x equals 78 divided by 4. Is that possible? Square root of 2 times 3 times. So it would just be the square root of 78.
Is this what you mean?
Yeah, x equals square root of 79 because you can't divide it any further.
The 78.
Yeah.
If this is what you wrote, I would give you 5 out of 10 points for this answer.
Can it be simplified? I didn't think it could be.
It cannot be simplified.
The square root of x squared. Oh, plus minus. Yeah.
Yes. So you left out one of the solutions, so you get half credit. Now, I don't know, maybe that's being very difficult, but the point here is you have to take the positive and negative. It's going to become more important the more difficult problems we do. Okay. So the next type of problem here we'll look at, see if we can do that here. So some have reducible roots, some don't. Here's another problem for you to think about. I'll put in front of you. Your goal is to isolate the x squared. So you're going to move things around until you get just x squared on one side of the equation.
Okay. And then plus 180. So then 180 divided by 5. 80 divided by 5. 36. So then x squared equals 36. So then x equals 6.
Is this your final answer?
Yes. Oh, no, plus minus 6. Plus minus 6.
Okay. All right. Good. Okay. That's really good. Here's another type of problem that you might see. Let me snip this in. All right. So this problem here, when you isolate x squared, okay, you add 16 to both sides, you divide by 9. Now, when you take a square root, you have to remember that you can take the square root of a fraction. You take the square root of the top.
Yeah, and the square root of the bottom.
Square root of the bottom.
But you can't have a square root of the top. So you have to like multiply it by.
Yeah, if that happens, we'll address that, but I'm going to try to avoid rationalizing because that's not really emphasized here. So what are your final answers here, please, when you apply that to this problem?
So then you multiply square root of 9, so the square root of 54. So you get the square root of 16 over or no, you just get 16 over the square root of 54.
Okay, I'm hearing some things I don't like. You're taking the square root of both the top and the bottom.
Yep.
Square root of 16, square root of 9.
You multiply it by
Those,
the, oh wait, no, it's
those,
16 times 9.
Right. Well, you could do that, which still works, but that's too much. Like if you can, if it's a reducible root, you just reduce it. Square root of 9 is a known value. It was what I'm trying to say. You're
okay.
overcomplicating.
So it'd be 4/3. So I was just like taking an unnecessary step.
What is your final answer in the box here?
Plus minus 4 divided by 3.
Okay, good. All right. So let's go back to another type of problem here. So all this is kind of set up for the like more difficult problems, just trying to cover all the scenarios that you might see before we get into the other stuff here. Go ahead and give this one a try, please.
Negative 80, so then x squared equals 20. Then we did. So x equals 2 times square root of 5. Plus minus 2 times square root. 2 times square root of 5.
Good.
Yeah.
Okay, I like that. All right, so the next type of problem you will see is something like this. X minus 1 squared minus 25 equals 0. And I've been saying for a while here, you isolate the x squared, but that's not really possible here. You're now going to isolate, just cross that out, that'll be better. You're now going to isolate like whatever is being squared. Okay, so in this case, you're going to isolate the x minus 1 squared by adding 25 to both sides. When you take a square root of both sides, plus or minus,
So you get x minus 1 equals 5.
plus or minus 5.
Yeah.
So there's two possibilities, and you either write them horizontally like this, x minus 1 equals 5,
Or
x minus 1,
plus. Yeah.
or you can write them, vertically, like doesn't matter, you pick, but you have to solve both of these now. You can't just solve one of them because it looked better than the other. You have to do them both.
Yeah.
All right, so go ahead and well, we'll just finish this one up. X equals 6, x equals -4. So in the previous, all the other previous problems was always like plus or minus, right? They're not always just opposite. In fact, that's unusual for them to be opposite like that. This is the more common type that you will see.
Yeah.
All right, I'm trying to find one here that we haven't done yet. Here we go. Let me give you new one here. Let's have you try x minus 3 squared minus 81 equals 0. You solve that and give me the roots, please.
So then, so it's 81 equals. So it's actually, so x minus 3 equals plus or minus 9. So then it'd be x equals 12 and x equals 6.
So your answers are 12 and 6.
Yes.
Okay, I'll give you half credit again.
Is it plus or minus 12 and plus or minus 6?
There's only two solutions, so 12 is correct. And here's how I'm checking, by the way. I'm just 12 minus 3 is 9, 9 squared is 81.
6 minus 3 is 3, 3 squared is 9, 9 minus 81, not 0.
You said it correctly earlier. You said it was x minus 3 equals 9 and x minus 3
Yeah.
equals -9, I think. I heard that.
Oh, I forgot. Oh no, I kept the 9, so then it'd read -12.
No, the 12 is correct.
No, oh, sorry, no, it'd be negative. Wait, so -9 minus -3 is -6. -6 squared is 36. That's not right.
Right. You're adding 3 to both of these. X
Yeah.
equals 12. Adding 3, x equals -6.
Oh, it's -6.
Yes.
But when you plug that back in, that doesn't work.
-6, -9. Think of you owe someone $6, then you owe them $3, you owe them $9.
Oh yeah, you solve inside first. Okay.
Yeah, and you
So
might
it
think,
does.
you might say, well, I had 6. I mean, well, yeah, I mean, but -6, completely opposite side of the world.
Yep.
All right, here's another one for you to try. Please make it a little bigger to see visually.
So then x minus 14 equals plus or minus 1.
Okay, keep going.
So then you add 14. So then you get x equals 15. You add 14, you get x equals 13. I got 15 and 13.
Very good. So we've seen scenarios now where they're both positive, one's negative. You
Yeah.
cannot try to predict the answers. You just have to work them out and hope that works out the way you want here. Okay, looking for some other ones here. These all work out nicely. All right, so new problem. This one does not work out as nice as the others, so I'm just gonna throw it in front of you, see if see what you do. Chance to see if you are comfortable with sort of these ones that are unfriendly.
Okay, so it's plus 1. It's 10, so then. And then you multiply it by 2, so you get 20, so x plus 1.
You don't multiply by 2, you divide by 2.
Oh, so then you get equals 10, or plus or minus 10.
Try again.
So you add 1. Oh, wait, no, because so then it'd be 5. So x plus 1 equals plus or minus 5.
I get the impression you're not writing anything down because there's too much to remember here, and you're making.
No, I did write it down.
Okay. So here's what you said, and here's what I think you said this, and I think you meant that. So you didn't have the root in there.
No, because it's still squared. I thought I hadn't
Oh,
gotten
I
that.
see. So you're, yeah, and that's, so we gotta, here, let me get this down. It is this. And you're going to take a square root of both sides. That's when you put the plus or minus in front, but you don't know the square root of 5. And the root on the left does go away.
Okay.
Okay. So this one,
okay.
this one didn't work out. Like all the other ones, it was like the square root of 25 or 36 or something. And now it's like, what do I do? You still subtract 1. This time though, and this is a preference, you put the number in front. So it's -1 plus or minus the square root of 5.
And that's an answer?
That's an answer. And it's not nice. Like, it's not like you're used to, it's not like 2 or 3.5 or whatever.
Oh, it should be x equals -1 plus or minus square root of 5, and x equals 1 plus or minus.
So -1 plus the square root of 5, -1
Yeah.
minus the square root of 5.
Yeah.
Okay. It's okay to leave it in this form on the left. Sometimes they want you to break it apart here like this.
Okay.
All right, so here's another one to try. There's no way to kind of look ahead to know if they're going to work out nicely. So you just go through the manipulations, undo addition and subtraction, undo multiplication, division, then take a square root. If it works, it works. If not, you just keep going with the number there. But give this one a try. It's a lot like the previous one.
Okay. So then so you get 15. So then 15 divided by 5 is 3. So x minus 7 squared equals, or the square root of x minus 7 squared equals the square root of 3.
Okay.
So then you get x minus 7 equals the square root of 3. So then it'd be x equals -7 plus or minus the square root of 3.
Keep in mind this, it's -7, so you'd add that.
Oh, so it'd be plus.
Yes, like this.
+7 plus or minus. Yeah.
Yes. Okay. So here's a new problem for us to look at. We'll work on this one together here. Actually, I need to rewrite it because that's not the one I want to do. 2 times x minus 3 squared plus 7 equals 31. Okay. So this time when you subtract 7 and divide by 2, okay, you get x minus 3 squared equals 12. Okay.
Okay.
When you take the square root of both sides, it is possible, plus or minus, that you do have to reduce this root.
Oh, because it can be reduced. So it'd
Yeah,
be
so
2 times the square root of 3.
So if it can be reduced, you should reduce it. And then you add 3 to both sides. So your answer is 3 plus or minus 2 square root of 3. I can't say, you know, when you will see that, or, you know, but you have to be on the lookout for it. It's like, it's just, you know, there's all these possibilities here. Of course, none of these have harder ones. So I'm running out of problems here. Work on that are, oh, here's something new. We haven't done any fractions yet, but this will work out nice. Sorry, just give me a moment here. You probably want to break anyway, so we can find some that
No, you're
work
fine.
out. Okay, so here's another type of problem you might see. 3x minus 6 squared equals 48. So in the past, it's just been, you know, x squared or like x minus or x plus something, but you can add more stuff here. It's the same path. You take the square root of both sides. Can you reduce the square root of 48 for us, please?
So divide by 4, so then 12, so then 2 times square root of 12, so then it'd be 4 times square root of 3.
Like this?
Yeah.
Good. Yep, that works. So you add 6 to both sides. So it's 3x equals 6 plus or minus 4 square root of 3. And then now you divide by 3, but you divide everything by 3. You can only divide the numbers, that the constants here, like these fractions, but on the right here, you can only divide the number out in front if
Yeah,
it
so it'd be
divides
4
this.
thirds times
Yeah.
square root of 3.
Good, really good. Okay, just seeing some really weird problems here that don't work out. Here's another one, I guess, to give you before we move on. We're gonna move to quadratic formula next. Here, let me just have you do this one. 2x minus 3 squared equals 24. Can you solve that for us, please?
Okay. So then could I take the square root of 24 first? Or is that
Yes,
like what I'm supposed to do?
you have to. Yeah, there's not an option here. There's kind of a like, you will undo the square root first.
Okay. So then square root of 24 is 4 times the square root of 6. Yeah, and you can't divide that any further. So 2x minus 3 equals 4 times the square root of 6.
Hang on. So you said 4 square root of 6. So here's how I check that. I square this number and multiply it by this number. And I should get the number here.
Oh, wait, no, it's 2 times the square root of 6. It's 2 times
Okay.
square root of 6.
All right. That's how you check them as well, if you ever, you know, are unsure.
Okay. 2 times square root of 6. And then oh yeah, I have to divide by 2 and then, or I can add 3 first, I
You
guess.
should, yeah, add 3 first.
Then 2x equals 3 times 2 times the square root of 6. And then
Do you have your,
x equals 3 halves times the square root of 6.
yeah.
Oh, it's plus or minus. That's where the plus or minus goes.
Yeah, it,
Okay.
because I mean, you had it at some point where you said, okay, it's 2x minus 3 equals plus or minus 2 square root of 6. Maybe our discussion over here got you sidetracked on that. Any, do you want some more questions on this, or do you want us to move to quadratic formula?
I'm not really sure what the quadratic formula is.
Yeah, we can cover it in the time we've got. Okay, so we're gonna look at, we're gonna actually look at problems you already know how to solve, and we're gonna just solve them differently, at least initially. If I asked you to solve for x, what would you do here?
Probably, oh, I have to factor it, and I have to
Okay,
factor it.
so go ahead and factor it, set them equal to 0, and give me the solutions, please.
Negative 14, so it'd probably be, has to add up to a negative. Oh, negative 7x and 2x.
Okay, keep going, work this out fully.
So then x minus 7, and then, oh wait, no. Yeah, no, x minus 7, x plus 2,
Okay, so what are the two x values?
7, negative 2.
Okay, so we know the answers are 7 and negative 2. Would you agree with that? Like, no questions on that, right?
No questions on that.
Okay, so we are now going to use what's called the quadratic formula to solve this problem. And here's the thing that's nice about the quadratic formula is it always works. Okay, so you might
Yeah.
ask the question, well, why didn't I learn it until now? That's a separate topic. You're going to see that this always works, but you may not like how it works, especially for a problem like this one. But nevertheless, here I will show you the quadratic formula. So there's this standard form of a quadratic, ax squared plus bx plus c equals 0. A is the number in front of x squared, b is the number in front of c, I'm sorry, in front of x, and c is the constant. In your problem, a is 1, b is -5, and c is -14. Is that clear so far?
Yeah.
All right. Now, some classes, maybe your teacher will even do this. They derive the quadratic formula from completing the square. We're not going to do that because that's not important right now. I'm just going to give you the quadratic formula. Minus b plus or minus the square root b squared minus 4 ac all over 2a. Okay. You might have seen this formula in a previous class and they just had you put numbers in and you just simplified it. But now you have to remember it. You have to memorize it, be comfortable working with it. And here's how it works. You take those A, B, and C values and you substitute them into the formula. Now, as a reminder here, you really want to substitute in parentheses.
Okay.
So it's like this, minus a -5 plus or minus the square root -5 squared minus 4 times 1 times 14 all over 2 times 1, like that.
That looks complicated.
It is. So most of the mistakes are made by not putting the numbers in correctly, not using parentheses, and then mostly under the square root. And I didn't make the classic mistake where I didn't put, it's -14. I put in 14. So that would have already caused us a problem.
Okay.
Okay, so we're going to focus our attention on the square root part. Can you simplify this for me, please? -5 squared minus 4 times 1 times -14, and tell me what you come up with.
Um, -25 minus 4 times -14. So I got 81 divided by 2. So I got 40.5.
No. Just the part under the square root, just this part.
Oh,
-5 squared minus 4 times 1 times -14. I wrote this because
81.
I heard something that suggested you were going to subtract and then multiply. No. You multiply all three.
Oh, should be -14. Oh, well, I still would have gotten the same answer, I think. So I got 25, or I got 81.
No, let me grab this, bring it down here. And this is what, it's good that we're doing some practice on this so that you can see -5 squared is 25. 4 times 1 times -14 is, I'm sorry, you did have it correct, plus 56, which is 81. Is that what you said? I'm sorry, I
Yeah,
heard
that's
something
right.
totally different. I really apologize. Okay, that is the first place to start. 5 plus or minus the square root of 81 over 2. Okay. You know the square root of 81. You know that value. That's 9. So this is 5 plus or minus 9 over 2. Again, order of operations, there's implied parentheses in the numerator. So you have to break this apart as 5 plus 9 divided by 2, 5 minus 9 divided by 2. Can you tell me what those become?
So that's 14. So it's 7 and negative 2. Yeah, 7 and negative 2.
And we shouldn't be surprised because you already solved it up here and told me that the answers are 7 and negative 2.
Yeah, but so the quadratic formula is just like a more complex way, but it always works.
It always works. And you might, you know, you're a good math student. You're gonna want to know, well, like, why would I use this, or when would I use this? And you would never use it on this problem right here. You would just never do that because it
Because it can
works
be
with a,
factored.
yes. But if it can't be factored, that's when you do use it. Okay. Now, before we can move on to like the ones that are unfactorable, that are harder, where this comes into play, I need you to attempt to work through this on your own here, or with my help, at least a couple of examples. Okay. So this one actually, again, can be factored by grouping. It's a little bit more work than the previous one, but you could get the answers here. But we are going to again use the quadratic formula. A is 2, B is 3, C is minus 20. I recommend writing out the formula every single time until you feel like you know it, because you will be expected to have it memorized for the test here. All right. Make sure you substitute in parentheses, even for positive numbers. Even for the positive numbers, just put them in parentheses. All right, so I'm going to try not to tell you that you're wrong when you're right here. Could you simplify what's inside parentheses here again, please?
Yep.
Or under the root, I'm sorry, under the root.
Times 3, so 9. So that's negative 40 times negative 4 is 160, or 160. So I got 169.
Yes, and you should say, oh, that's good, because I know the square root of 169, or at least it's within the realm of possibilities. And I guess you're usually allowed to use a calculator.
Yeah, I have a
Okay,
calculator.
okay. So the square root of 169 is 13. This becomes minus 3 plus or minus 13 over 4, and you break it apart. Okay, minus 3 plus 13 over 4, minus 3 minus 13 over 4. Order of operations, numerator comes first. There's implied parentheses there. They're just not written. So this is 10 over 4, or 5 halves. And then on the right is minus 16 over 4, minus 4. Again, but you probably, if I gave this to you, you probably would have and just factored it, and you probably would have done it as fast or faster. Okay. But again, we're leading into the problems where it's like, you really want to use this formula. So one more here for you to try. 4x squared plus 8x plus 3 equals 0. I'd like you to solve with quadratic formula here. I'll grab the formula again for you. Excuse me. And have you work this one out on your own. It works out nice in the sense that there are no square roots, but that's all I'll say, I guess, for now on this one.
And it goes A, B, C, right?
Well, A is always in front of x squared. So if they
Okay,
rearrange this,
so B is the one with just X, and C is usually, or C is always just the numeral.
yeah, and they have to all be on one side of the equation. You'll see that where they're mixed up. But yeah, good questions. I like that.
Eight squared minus 4 is 4 times 3. And that's over 2A. 2, or actually 2 times 64. Okay, so then that's -8 plus minus square root of 64 minus 4 times 12 over 8. And then -8 plus minus 64 times -3072.
Whoa, hang on. I'm hearing numbers that are really large. Are you working on the part inside the root?
Yeah,
Okay, 8 squared minus 4 times 4 times 3. 4 times 4 times 3 is 48. 8 squared is 64.
oh, it's minus.
Yes,
Oh, it's still a minus? I thought it
yes.
was -4 times 12.
It is always minus. So this is a minus.
Oh, that's not a negative symbol?
No, sorry for making that unclear.
Oh, okay.
I see why that
Yeah,
that's good.
okay.
That's why we're practicing, you won't make that mistake again. You're gonna
Yeah,
say these are way too large to deal with.
yeah. So then that's 64 minus 48. Okay.
Okay, keep going.
-8 plus or minus square root of 16 over 8. And -8 plus minus 1/2. So I got negative or x equals -8 plus minus 1/2.
Okay, so you have to, we've done this a few times where you've got to do the numerator first,
Oh, okay.
then divide by the denominator. You can't choose which one. So
Okay.
maybe reset from there.
So then it'd be x equals -8 plus 1/2. X equals -8 minus 1/2. So then x equals -7.5, and x equals -9.5.
Okay, so still not quite hearing what I want here. So it is -8 plus or minus the square root of 16
Divided by 8, I thought. Yeah, divided by
divided by
8.
8. Okay, what is the square root of 16?
4.
Okay, so this becomes -8 plus or minus 4 over 8. You have to do what's in the numerator first. -8 plus 4
Oh,
over
I
8.
thought I thought the -8 plus or minus was like on the other side. Like wasn't involved in the
It is, yeah. You can see, like, if you go back to the formula, it's really this whole thing is in parentheses. You do the top first.
Oh, okay. So then it'd be -8 plus 4 and then -8 minus 4. So then that's -4 and then -12 all divided by 8. So you get x equals -1/2 and then x equals -3/2.
Yes, yes.
Okay.
Now I'm hearing good stuff. Okay. Like it. Okay. Now again, like, these are, when I say nice means integers, fractions, which are rationals. Those are nice. That's not why I use the quadratic formula. Okay. Use quadratic formula for a problem like the following. Okay. And let me set it up here. X squared minus 3x minus 3. Okay. So you look at this, you're like, oh, maybe I'll try factoring. You factor, you look over and over again, you're like, all right, two numbers that multiply to -3 but add to -3. The problem is sometimes they look like they should work and they just don't. And you're like, why doesn't this work? Okay.
Yeah, it won't work because they're the same number.
Yeah, and that's not always true. If there's perfect square trinomials where they can be opposite in sign, so just be careful with that one. If we graph this real quick, you see that the answers are not nice at all either. I know you wouldn't have a graph, but that's always kind of the thing to look at here. So that leads you to like, well, how can I find the answer? Well, quadratic formula always works. A is 1, B is -3, and C is -3. So we have x equals -3 plus or minus the square root -3 squared minus 4 times 1 times -3. Yeah, and again, that's a subtraction all over 2 times 1. So let's just focus on the part under the root now. Can you tell me what that simplifies to, please?
So then that's 9 minus 9 plus 12. So then that's 21
It's 21. And from
squared.
earlier, yeah, from earlier we know that, okay, that doesn't work, meaning there's not a way to simplify it. So maybe this is better because there is nothing to do here. You just leave it as is, and now you divide each of these by the 2. So typically they want you to show the answer where you're dividing them, even if you can't actually divide it, but they like it to be written this way, like 1/2 or square root of 21 over 2. This is your preferred answer. And you can see this actually was pretty fast because it was the right strategy to use for this. Questions on that?
No.
Okay, so here's one for you to try. I should have just snipped in the formula, so I'll do that now. Does it help to see this before you see it in class, or is it better the other way around where you've seen it in class and then we do some problems?
Probably easier here because then I can like get an understanding before class.
Okay. So this one's really similar to the last, but I think it was minus 3x here. But you can see there's not two numbers that multiply to -3, but add to -1. So your options are quadratic formula or completing the square.
-3 and 1 or wait, no. To add to -1 but multiply to -3.
Yes.
So that doesn't exist.
That's right. So you have to use quadratic formula.
So then negative b. Okay. And then -1 or no, +1 plus minus square root of 1 minus 4 times 1 times 3. So then 1 plus minus square root of 1 minus 12. So 1 plus minus square root of 11. That's not going to be a nice one over 2. So then
Okay.
we have to do 1 plus the square root of 11 and then 1 minus square root of 11 divided by 2. So then it'd be 1/2 plus the square root of 11 and then 1/2 minus the square root of 11. Is that it?
You said it's square root of 13.
It's 13.
Yeah, I think you had just a small sign there because it's -1 squared. That's your b minus 4 times 1 times -3. And then this is
It's 1. Oh, it's 1 plus 12 because it's -3. Okay.
yes,
Yeah.
yes. So I heard 1/2 plus or minus the square root of 13 over 2.
Yeah.
That is correct. Yeah, good. Okay, a couple more here that we can do. Trying to keep the numbers fairly small here. So you kind of asked this earlier. I didn't really want to introduce it until we'd done a few. This is not in standard form. And so you cannot just start labeling A, B, and C. You have to move everything to one side.
Yeah, so it'd be x. So x squared plus x minus 1.
Yeah, and then you can go on from here and all this. So let me grab the quadratic formula again.
Alright. And then -1 or plus minus square root of 1 minus 4 times 1 times -1. -1 plus minus square root of 4 times 1 times -1, so then 1 plus 5. So -1 plus minus square root of 6. So that'd be -1 plus square root of 6 over.
Check your number under the root is not quite right.
I didn't get the number under the root yet.
Okay.
So then 2 times a is 2. So I got -1 plus the square root of 6 divided by 2, and then -1 minus the square root of 6 divided by 2.
Okay, really close here. Again, that part under the roots. This is the most messed up part. 1 squared minus 4 times 1 times -1. 1 plus 4.
Yeah, I got. Oh wait. Oh wait. I got 1 plus. Did I get 5?
It may be the way I'm
Oh.
writing it. Hopefully, seeing it in the nice typesetting, you can see that it is multiplication. Clearly, not sure. So you get a small change to your answer. I think you wrote -1 plus or minus the square root of 5. They're both divided by 2, like that. All right, so let me really quickly show you a problem. Another possibility here with quadratic formula. So this factors into x plus 2 squared equals 0. So this is the solution of -2 only. A equals 1, B equals 4, C equals 4. So if we apply the quadratic formula, -4 plus or minus the square root 4 squared minus 4 times 1 times 4 all over 2 times 1. Notice inside the root here, it's 16 minus 16. What does that become?
0.
There. So it is possible for it to be the square root of 0. And then you just get one solution, but you're supposed to
I
know
was
that
gonna say
is
it's
a,
square root of 0, 0.
yeah, at least in the real domain, it is. All right, and that's a double root. Okay, I don't know that you'll see that because you would never use quadratic formula on a perfect square trinomial, but
Would it be also like called a repeated root?
yes, that's probably the more formal way. All right, well, that's probably going to take us here to the end of our lesson for today.